Okay, so we are going to do a quick refresher on the imaginary numbers. We saw them a little bit in this last unit. We're going to see them even more in this upcoming unit. So let's just make sure that we remember what we're talking about here. Okay, everybody with me? So I'm sure you recall that the I, sure, is just equal to the square root of -1, right? So when we go to do I squared, you remember from the last unit, that just comes out to be -1, because the square roots will cancel each other out. We'll just get -1 there. So what do you suppose I to the third is going to be? Jake?
-I.
-I. Think about it. If you take -1, here's me doing square root of -1 all by itself. Square root of -1 times square root of -1 gets me -1. Times it by one more square root of -1, I end up at -I. And what do you get when you have to do I to the fourth, do you suppose? Cedric?
1.
+1. What's so neat about this is now a cycle that just continues over and over and over again, because if you think about it, if I multiply times one more I, don't I just get, right? 1 times I is just going to be I, and then I just have this cycle that continues over and over and over and over. So I to the 6th, everybody, would be -1. I to the 7th would be -I, and I to the 8th, +1. Okay, so that's great when you have it in front of you and you have a list. But what about, let's jump to I to the 43rd power. I certainly wouldn't expect you to like go all the way up, right? We have until 8. You're not gonna. So everybody take a moment, decide for yourself. It's gonna be one of these 4 things, right? Because that's what you're gonna get every time. So take a moment and see if you can figure out what that is. I'll talk to you about how I do it.
I'm just trying to remember the spell check. I remember she spent like 5 years.
How well do you remember it?
Not well.
I mean, you can reason your way through it, right? You see a pattern unfolding here. All right. Let's do by a show of hands. How many people think it reduces down to just the I? How about -1? How about -I? I got a couple there. How about +1? The negative i's are correct. So without finding all of your values from 1 all the way up to 43, what do you notice? Well, someone walk me through what they did. Cedric, go ahead.
I found out that like the 1 was like a multiples of 4.
I do the same thing. If your exponent is a multiple of 4, check it out. It just reduces down to be a 1. So anytime you have an exponent that is a multiple of 4, 12, 16, or so on and so on, that's just going to be a 1. So if I'm looking at my number, okay, 43 is not a multiple of 4, but what I do in my head is like, okay, well, 44 is. So if I were asking what I to the 44th were, it would have been 1. So I need to be, I'm not quite there yet, I'm 1 before it. So I'm at -1. So I just asked myself, okay, give me a multiple of 4 that's close to the number that I'm looking for. And then I just go up forward or back a couple, whatever I need to do. So when you go to do 645, you have it?
Yeah, I think so.
What is it?
I got that.
I believe you're right. Well, that's true, but I'm really kind of focusing on those multiples of 4. Do you remember the rule how to tell if a number is divisible by 4? You know what the rule is? Wait, what? I'm hearing some different answers.
Don't you add all things? No.
That's the test for 3 and 9. Anybody remember the rule to test if a number is divisible by 4? You just look at the digit form by the last 2 digits. So in this case, 45. 45, 4 does not go into it. So the number 645 is not a multiple of 4, but it sure is close to 1, right? 44 again. 44 would have been a multiple of 4. I have to go one more past it. So I end up at just I. So no matter how long a number is, all you really care about is the last 2 digits. That number, if that number is divisible by 4, then the whole thing is. Isn't that neat? Can you think about why that works? Like why 112, for example. 12, 4 goes into 12, so 4 goes into the whole thing. Exactly. 4 can go into 100. 4 can go into all the multiples of 100. So if it was 612, doesn't matter because I know 4 can go into 600 because it goes into each 100 evenly. So then I just need the remainder to be a multiple of 4. All right, let me give you one more. What if it was I to the, I don't know, I'm going to make up a number. 1, 2, 3, 4, 5, 6. So really big number, but totally doable. Go ahead.
Oh, just kidding. Yeah, isn't it?
I think it's one.
Grace, don't laugh at me.
That is a multiple of 4. Again, if I just look at 56, right? If you don't know off the top of your head that 56 is a multiple of 4, you know that 40 is, right? And then you just have 16 more and you're like, oh yeah, okay, 4 totally goes in. So anyway, we remember that, or we can handle that. All right, great. Now let's take a look at our complex numbers. So a little refresher of what they are. They're going to have 2 parts. They have a real part, which is going to be there, and the imaginary part is going to be here. Okay, real and imaginary. So flip the page. Let's see what we can do with them. Here we have 2 complex numbers, Z1 and Z2, a -2 plus 3i, and then Z2 is 4 plus 2i. So let's just take a look at the very first thing they want me to do. They want me to add these 2 complex numbers together. All right, thank you so much. So let's go ahead. I'm going to write -2 plus 3i, and then I want to add that to the second number, 4 plus 2i. I's conveniently work just like a variable until when do they like kind of change a little bit? Exactly. When I have I squared, I just turn it into that -1. So we have a little bit of we were just working with this in the last unit, so hopefully this is easy peasy. So I'm just going to combine my terms like I normally would. I'd get 2 plus 5i. That's my answer. I'm done. I can't go any further than that. That's it. Try the second one where you're subtracting them. I'll give you a moment to do it before I'm curious what your answers are going to be. Thank you. Thank you. You have it? Go ahead, Mackenzie. -6 plus I. All right. So make sure Z1 -2 plus 3i. When you are subtracting, this number has 2 parts. You have to subtract the whole thing. So please make sure that you distribute it. It should be a -2 plus 3i minus 4 minus 2i. And now combine your like terms. So I agree with the -6 plus I is perfect. Okay, let's multiply. Again, these are two-parters. You're gonna have to FOIL that out. In the last unit, everything that we did this on, like the middles canceled out, they're not going to cancel out necessarily here. Because these are not complex conjugates of each other. So take a moment. Kenzie, you got this one too?
I got -14 plus 8.
-14 plus 8i. Yeah, all right. So I'm gonna FOIL it real quick. -8, outsides minus a 4i, insides plus a 12i, and then last, be careful, that's gonna be a plus 6i squared. All right, my middle terms are gonna combine like normal. So that's a plus 8i. But now please be careful. Whenever you see an I squared, what's it really? -1. So this is really 6 times -1. So you've got a -6 right there. So -6 and a -8, that's where that -14 is coming from. By the way, get in the habit, if you're not already there, whenever, I guess that is one other difference from when we're dealing with a normal variable, we always put I at the end. So you wouldn't have 8i minus 14. I mean, it's not mathematically wrong, but we always put square roots at the end, right? Like you would always say 2√3. You wouldn't say √3 times 2. You know what I mean? So we always put the square roots at the end. And since that's technically a square root, that's why it goes at the end. If it truly were just a variable, right? If it was an x, we wouldn't write it that way. We put the x term first and then the constant at the end. So anyway. How do we divide? Oh boy. Let's try this. So you have -2 plus 3i. We're going to divide it by 4 plus 2i. Thoughts? Do you remember? Mackenzie, go for it.
Is that where you like you multiply by 4 minus 2i?
Yes. You need, the whole problem with this is that you have a square root in the denominator. You're not allowed to have square roots in the denominator. So the only way to get rid of them is to multiply by the conjugate. 4 minus 2i over 4 minus 2i. If you remember on the bottom, I'm going to multiply the denominators together first. It's going to work like magic that the i's are going to go away if we did it right. So I get 16. Outside, inside are going to cancel because that's a conjugate pair, right? You'd have a -8i and a plus 8i. I'll write it, but you don't have to. Because they're just going to cancel. But then those last, positive 2i times a -2i, -4i squared, right? So the 8i's cancel. And then what happens with that I squared? Yes. That's a little bit. -1. This I squared turns into a -1. So you have -4 times -1. That's really a +4. So my whole denominator is really now just a 20. And now we just got to multiply those numerators. This could have I left in it, probably will. So let's see, a -8. And have a +4 and a +12. So a +16. And then a -6i squared, which is really let me ask you this question. Is this a fully simplified answer? Right. As long as all 3 pieces have a common factor, you can divide by that common factor. What you can't do, if that were like, let's say that were, I don't know, 17i instead of 16, you can't just divide the 2 and the 20. It has to be all 3 or nothing. But since all of them, I can divide by 2, right? My fully simplified answer would be a -1 plus 8i over 10. You can't go any further though. Don't try and simplify that 8 and that 10. You can't. Has to be all the pieces, everybody or nobody. We're all right? Try Z1 squared. I like to write it out. I like to see it. That one shouldn't be too bad. You have an answer? What'd you get? Anybody else get -5 minus 12i? All right, perfect. I'm gonna FOIL it real quick. Get a +4. We're gonna get a -6i and another -6i. Last would be a +9i squared. So that whole chunk is really a -9. So I like the -5 minus 12i. It's perfect. All right, last one. Try it. You already have Z1 plus Z2 right there from the first problem. If you want to just take that answer and square it, divided by Z1, see what we get. Thanks. Sure. You left your phone somewhere? I have a I have a final answer. I wonder if, did you get the same one?
Yes.
Oh, good. Mackenzie, you got that too? There is everything I did. Oh, sorry. Where? Yeah. When you multiply by the conjugate, right, the outer and inner will always cancel?
They always will.
As long as you're multiplying by the conjugate, yes. It's not a bad idea to actually do it out, because sometimes you'll catch yourself, like if you didn't do the conjugate right. And it's not, if you end up with still having an I in your denominator, then you know, like, oh, I messed that up. Maybe I did multiply by the conjugate. Yes.
Mine came out wrong because instead of like the
Oh, yes. Yeah, it can be frustrating. So just to walk you through mine, what I did. So we already had the Z1 plus Z2 right there. So the first thing I did was square it. And then I was gonna try and do with my denominator, but I realized, oh, I need to multiply the whole thing by the conjugate. So once I had that new numerator multiplied by the conjugate, which remember is just the same as the original, you just change the sign in the middle. You don't change the sign of the first number, it stays. And if you do that, the whole denominator should just become a 13. And then you just gotta FOIL that numerator together. Beep, bop, boop. I guess I didn't check if that could be simplified any, but I don't think so. No, I can't. Thoughts? We kind of remember? All right, so I just have some for you to practice today. And then that's it. Let me just pass these out and then I will come back.
Oh my God.
Okay, yes, I do want you to do all of them because the first like 6 are so fast and easy. There's only 18.
Okay, let's see.
Just like that.
What? You did all?
Yes,
You guys
oh my
listen?
gosh. Yeah, you've got 25 minutes. Yeah. No,
That's great.
just like that.
Hopefully those things like this are real and I'm